Hi everyone, I'm going to work through the practice reactions of aromatic compounds on page 411 of your textbook. So here's the first question. Paradichlorobenzene treated with chlorine and iron 3 chloride. So I've got paradichlorobenzene drawn. I'm just going to add chlorine, Cl2, and then above the arrow I'm going to write the FeCl3 because it's a catalyst. So it's completely regenerated at the end of the reaction. So to complete this problem, I draw para-dichlorobenzene again, exactly how it appeared in the reactants. And then what I have to understand is that the combination of chlorine and FeCl3 gives me something called an electrophile, which is an electron-loving group, Cl+, which is going to add right onto the ring. So I can basically put that anywhere for now. I'll just put it there, and that's my product. You can also put a plus HCl here. That's going to be a byproduct, but it's okay if you leave that out. Really what I'm concerned with is the major product, which is here. This is paradichlorobenzene treated with nitric acid and sulfuric acid. I'll add the nitric acid plus HNO3, and then I'll put the sulfuric acid above the arrow, H2SO4. It's acting as the catalyst. The product is just paradichlorobenzene. Put those chlorines on para to each other. The combination of the nitric and sulfuric acid produces an electrophile that's a nitro group, NO2. That will go in the ring on any one of these empty carbons. And the byproduct of this reaction is water. So you can write that in if you want to. The last problem in this set is a sulfonation reaction. We're going to add sulfur trioxide, or SO3, with a sulfuric acid catalyst, which goes above the arrow, H2SO4. The product will be paradichlorobenzene, and the sulfur trioxide and the sulfuric acid create an SO3H electrophile. When I put that on the ring, I get my final product, and we're not going to put any byproducts on this reaction. This is problem 1332, and the question is, when toluene or methylbenzene is treated with chlorine and iron 3 chloride, a total of 3 products are possible. Draw the structure of the 3 products and give their UPEC names. I've drawn toluene. I'm going to add chlorine, Cl2, and iron 3 chloride as a catalyst above the arrow. And I know that the combination of the chlorine and the FeCl3 is going to give me a Cl plus electrophile. So I know there's going to be 3 products here. I'm going to draw 3 arrows. And all I need to do is realize that I'm going to be able to get 3 isomeric products because the chlorine electrophile can add in 3 different positions relative to the CH3. It can add in the ortho position, it can add in the meta position, or it can add in the para position. So this first compound that I drew at the top would be orthochlorotoluene. The second one is metachlorotoluene. And the last one is parachlorotoluene. And that's it. Here's a summary of the 3 aromatic substitution reactions that you'll need to memorize. You're looking at a pattern here, but basically in all of these reactions you're taking a reagent with a catalyst and producing an electrophile or a positively charged entity which attaches to the benzene ring. So you'll need to memorize that the combination of chlorine and iron 3 chloride is a chlorination reaction, and it adds a Cl to the benzene ring. In nitration, the combination of nitric acid and sulfuric acid adds a nitro group to the ring. And finally, the combination of sulfur trioxide and sulfuric acid creates a compound called benzene sulfonic acid, and it adds an SO3H group onto the ring. The last reaction that you saw in your notes was actually a reduction reaction, and you don't need to memorize this one, but you will need to use it in your homework assignment. This reaction is used to reduce this NO2 group here to an NH2 group. And this creates the compound aniline, which is manufactured to produce things like polyurethane and even certain medicines, like it's the precursor to making acetaminophen or Tylenol, which is a very popular drug. But this last one, you don't have to memorize for the test. The first 3 you do. Good luck with your homework, and I'll see you in class.